We're going to be having a look at the least squares regression line of best fit. Now, you probably have already done your line of best fit, and you've probably already done it using your calculator. You'd know that we can get the line of best fit for a scatter plot data set using the equation y equals a plus bx. And we can figure out the values of a and b using a calculator, using stat mode. Okay, so this is something that we should be able to do. However, there's actually another way we can do it. And this actually comes down to the actual definition of how this least squares regression line actually gets done. And so you need to look then at your formula sheet in order for you to find the answers. And you'll find it right under statistics, and you'll see that there's two bits. In the statistics section, there's the least squares line slope, which looks like this. B is equal to, and then sum over sum, and then all of these brackets and all of this stuff. And we're just going to ignore that and then see what it's also equal to, which is r sy over sx, which looks far more manageable for where we're sitting. Okay, so we only need sy, sx, and r. We could ignore the whole thing in the middle. It's a more complicated process that we don't need to go through. And for A, we get a similar thing. It's the next one down. So the least squares line, in brackets, intercept. And so this is A is equal to y hat minus bx hat. Okay? So these are an alternative way of calculating our line of best fit. Now you'll notice you need a fair few pieces of information. You need r, sy, sx, y hat, x hat, and you need b, which you calculate in the first step. Okay, so you need all of these pieces of information in order to calculate your line of best fit. And both of these formulas are just on your formula sheet. So the way we use it is we do so. So the two formulas, once we ignore all of that, let's just get rid of it. So away with you. We're not going to be using that section of it. So we're instead just going to use this little bit, and we're going to move that over. Okay, so these are the two equations we're going to be using. So you need a fair few pieces of information to go through. So let's actually talk about what each of these pieces of information actually are. So Sx is the sample standard deviation of x, meaning if you have a table of data and you have your x and you have your y and then you have a bunch of numbers, 2, 8, 5, 6, 7, 12, 13, 10, it's just the sample standard deviation of x, which we did a little bit in year 11, but you might have forgotten about how to actually calculate it. Okay? Sy is exactly the same, but of y. Okay? So if it's 20 and 13 and 10 and 16 and 84 and 2 and 3 and 9, well, it's just the sample standard deviation of y. Then we can move on to the other ones. Now, we should already know what r is. R is our correlation coefficient. If we're being technical, it's Pearson's correlation coefficient. There's different correlation coefficients. We just happen to use Pearson's correlation coefficient. And we can get that also using stat mode. Okay, so that's another stat mode one that we can get. The last two are probably the only ones that we'd be expected to calculate manually, and those are x hat and y hat. So x hat is the mean of x, and y hat dot dash 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 of y. Meaning, meaning traditional average. You add up all of the numbers. So in this case, if I wanted to calculate x hat, it would be equal to 2 plus 8 plus 5 plus 6 plus 7 plus 12 plus 13 plus 10 divided by, there are 1, 2, 3, 4, 5, 6, 7, 8 numbers here, so divided by 8. And that's how I could work out x hat exactly. Okay, so these two formulas can calculate our line of best fit for us, okay? And all we need to know is 2 sample standard deviations, 1 R coefficient, and 2 means, okay? 3 of these, actually all of these pieces of information we can get quite easily from a calculator, but let's have a go through and seeing what a standard question would look like. Okay, so given x hat equals 3.29, y hat equals 80, sx equals 2.56, sy equals 11.15, and r equals 0.94, determine the least squares line of best fit. And so the moment you start seeing funky looking things like x hats, y hats, sx's, sy's, and r, you're probably in a pretty good confidence that you're going to be using these 2 formulas. Remember, these are both on your formula sheet. And this should be pretty much the first thing that you should be looking to do. Y hat minus bx hat, okay? Now you need to make sure that you do it in the order that it's written on the calculator, on the formula sheet, meaning that you're going to calculate b first. So b is equal to r, 0.94, multiplied by sy over sx. Sy is 11.15 over sx, which is 2.56, and then b is equal to 4.09. So that's our b value, and now we can use our b value to find our a value. So a is equal to, well, that's a y hat. So y hat was 80 minus b, which was 4.09, we just worked out b, multiplied by x hat, which was 3.29, and that's equal to 66.54. And so therefore we get the equation y is equal to 4.09 plus 66. Oh, sorry, wrong way around, because remember it's y is equal to a plus bx. So that means a goes first, 66.54 plus 4.09x. Alrighty, and there is your least squares line equation. And with that, you could predict forward, or you could predict backwards, you could interpolate, or you could extrapolate. Alrighty, I'll see you in the next one. Goodbye.